The shortage of polyvinyl chloride, or PVC, conduit is a widespread issue affecting various regions across the United States. Electrical distributors on the West Coast, specifically in California and Oregon, have reported experiencing similar shortages and significant price increases for PVC conduit. Moving inland, wholesalers in the Midwest, including those in Illinois, Wisconsin, and Minnesota, have also faced challenges with reduced availability and subsequent higher prices for PVC conduit. On the East Coast, some electrical supply houses in Maryland, New Jersey, and Massachusetts have encountered supply chain disruptions that impact the procurement of PVC conduit. These disruptions have subsequently led to project delays and increased overall costs. There are several primary factors contributing to the shortage. Firstly, hurricane impacts have played a significant role. Hurricanes Fiona and Ian disrupted both the production and the transportation of PVC resin. PVC resin is a crucial raw material required for the manufacturing of PVC conduit. Secondly, high demand for PVC conduit has put pressure on existing supplies. Increased demand stems from a surge in construction projects and infrastructure repairs. The increased demand has exacerbated the existing shortage, creating a situation where supply struggles to meet current needs. Thirdly, ongoing supply chain issues are also contributing to the problem. The COVID-19 pandemic and global economic challenges have created complications in global supply chains. These complications have led to delays and general disruptions that affect the availability of various materials, including PVC conduit. Given these challenges, electrical contractors and companies are advised to proactively plan ahead and secure PVC conduit supplies as early as possible. This proactive approach is essential to avoid potential project delays and excessive costs. Several strategies can be employed to mitigate the impact of the shortage. Firstly, it is advisable to contact multiple wholesalers. Reach out to several electrical distributors in the area to compare availability and prices. By contacting various distributors, you increase your chances of locating available stock and potentially negotiating better pricing. Secondly, consider alternative materials. Explore the use of alternative materials, such as metal conduit, if PVC conduit is unavailable or prohibitively expensive. Evaluate whether metal conduit can meet the requirements of the project, considering factors such as corrosion resistance, weight, and cost. Thirdly, it's important to communicate proactively with clients. Inform clients of the PVC conduit shortage and explain the potential impact on project timelines and costs. Transparency and open communication can help manage expectations and avoid misunderstandings. Additional points to consider include evaluating project specifications to determine if there are opportunities to reduce the need for PVC conduit. For example, perhaps certain sections of the project could utilize alternative wiring methods or materials. Stay informed about the current market conditions and trends related to PVC conduit availability and pricing. This can help in making informed decisions about purchasing and project planning. Investigate the possibility of purchasing PVC conduit in bulk to take advantage of potential cost savings and secure a supply for future projects. However, this approach requires careful consideration of storage space and potential carrying costs. Maintain detailed records of all communication with suppliers and clients, including quotes, orders, and agreements. This documentation can be valuable in resolving any disputes or issues that may arise. Explore the possibility of using different sizes of PVC conduit if the originally specified size is unavailable. Consult with engineers and inspectors to ensure that the alternative size meets the project requirements and local codes. Consider adjusting project schedules to accommodate potential delays caused by the PVC conduit shortage. Prioritize tasks that do not rely on PVC conduit to keep the project moving forward. Review existing contracts with suppliers and clients to understand the terms and conditions related to material availability and pricing. Identify any potential risks or liabilities associated with the shortage. Explore options for insurance coverage to protect against financial losses resulting from project delays or material shortages. Invest in training and education for employees on alternative wiring methods and materials. This can increase flexibility and reduce reliance on PVC conduit. Consider using prefabricated wiring assemblies to reduce the amount of PVC conduit needed on site. These assemblies can be custom designed and manufactured to meet specific project requirements. Evaluate the sustainability of alternative materials and consider their environmental impact. This can align with corporate social responsibility goals and appeal to environmentally conscious clients. Stay up to date on any government regulations or policies that may affect the availability or pricing of PVC conduit. This can help anticipate future challenges and opportunities. Document any lessons learned from the shortage to improve future project planning and material procurement processes. Conduct a thorough risk assessment to identify potential vulnerabilities in the supply chain and develop mitigation strategies. This can help minimize the impact of future disruptions. Explore the possibility of partnering with other contractors or companies to share resources and negotiate better deals with suppliers. This can increase purchasing power and improve access to materials. Consider using technology, such as cloud-based inventory management systems, to track material availability and pricing in real time. This can improve decision-making and reduce the risk of stockouts. Develop a contingency plan for projects that are heavily reliant on PVC conduit. This plan should outline alternative materials, methods, and schedules that can be implemented if needed. Communicate regularly with clients and stakeholders to keep them informed of the project's progress and any potential challenges. This can build trust and maintain positive relationships. Monitor the quality of alternative materials to ensure that they meet the project's performance requirement. This can prevent costly repairs or replacements in the future. Evaluate the long-term cost-effectiveness of alternative materials, considering factors such as durability, maintenance, and energy efficiency. This can help make informed decisions about material selection. Invest in research and development to explore new materials and methods that can reduce reliance on traditional PVC conduit. This can lead to innovative solutions and competitive advantages. Advocate for policies that promote a more resilient and diversified supply chain for critical construction materials. This can help prevent future shortages and disruptions. Collaborate with industry organizations and trade associations to share information and best practices related to material procurement. This can foster a more collaborative and efficient industry. Consider using flexible metal conduit as an alternative in certain applications. Flexible metal conduit can be bent and shaped easily, making it suitable for tight spaces and complex installations. Evaluate the fire resistance of alternative materials to ensure that they meet the project's safety requirements. This is particularly important in commercial and industrial buildings. Consider using liquid-type flexible metal conduit in wet or damp locations. Liquid-type flexible metal conduit provides protection against moisture and corrosion. Explore the possibility of using rigid metal conduit in areas where physical protection is required. Rigid metal conduit is more durable and resistant to damage than PVC conduit. Evaluate the electromagnetic interference or EMI shielding properties of alternative materials. This is important in sensitive electronic environments. Consider using aluminum conduit in applications where weight is a concern. Aluminum conduit is lighter than steel conduit. Explore the possibility of using stainless steel conduit in corrosive environments. Stainless steel conduit is resistant to rust and corrosion. Evaluate the grounding requirements of alternative materials to ensure that the electrical system is properly grounded. Proper grounding is essential for safety. Consider using intermediate metal conduit, or IMC, as an alternative to rigid metal conduit in certain applications. IMC is lighter and easier to work with than rigid metal conduit. Explore the possibility of using electrical metallic tubing, or IMT, as an alternative to PVC conduit in dry locations. E&T is a lightweight, thin-walled steel conduit. Evaluate the cost of labor associated with installing alternative materials. Some materials may require more specialized tools or skills, which can increase labor costs. Consider using surface-mounted wiring methods as an alternative to concealed wiring methods. Surface-mounted wiring can be easier to install and maintain. Explore the possibility of using wire mesh cable trays to support and route cables. Cable trays can be a cost-effective alternative to conduit in certain applications. Evaluate the aesthetics of alternative wiring methods to ensure that they meet the project's design requirements. Aesthetics can be an important consideration in residential and commercial buildings. Consider using colored conduit to identify different circuits or systems. Color coding can improve safety and simplify maintenance. Explore the possibility of using pre-wired conduit to reduce installation time and labor costs. Pre-wired conduit can be custom designed and manufactured to meet specific project requirements. Evaluate the availability of fittings and accessories for alternative materials. It is important to ensure that all necessary components are readily available. Consider using cable cleats to secure cables to walls or ceilings. Cable cleats can provide a neat and organized appearance. Explore the possibility of using cable glands to seal cables as they enter enclosures. Cable glands provide protection against moisture and dust. Evaluate the temperature rating of alternative materials to ensure that they are suitable for the project's operating conditions. Temperature rating is an important consideration in hot or cold environments. Consider using heat shrink tubing to insulate and protect electrical connections. Heat shrink tubing provides a durable and waterproof seal. Explore the possibility of using wire connectors that are specifically designed for use with alternative materials. Proper connectors are essential for a safe and reliable electrical system. Evaluate the voltage drop characteristics of alternative wiring methods. Voltage drop can affect the performance of electrical equipment. Consider using larger conductors to reduce voltage drop. Larger conductors have lower resistance and can carry more current. Explore the possibility of using parallel conductors to increase the current carrying capacity of a circuit. Parallel conductors can reduce voltage drop and improve efficiency. Evaluate the ampacity of alternative wiring methods to ensure that they can safely carry the intended load. Ampacity is the maximum current that a conductor can carry without overheating. Consider using overcurrent protection devices, such as circuit breakers and fuses, to protect electrical circuits from overloads and short circuits. Overcurrent protection is essential for safety. Explore the possibility of using ground fault circuit interrupters, or GFCIs, to protect people from electric shock. GFCIs are required in certain locations, such as bathrooms and kitchens. Evaluate the surge protection requirements of the electrical system. Surge protection devices can protect sensitive electronic equipment from damage caused by voltage surges. Consider using uninterruptible power supplies, or UPSs, to provide backup power in the event of a power outage. UPS can keep critical equipment running during an outage. Explore the possibility of using generators to provide backup power for extended periods. Generators can provide a reliable source of power during emergencies. Evaluate the energy efficiency of alternative wiring methods. Energy-efficient wiring can reduce energy consumption and lower utility bills. Consider using lighting control systems to reduce energy consumption. Lighting control systems can automatically dim or turn off lights when they are not needed. Explore the possibility of using daylight harvesting systems to reduce energy consumption. Daylight harvesting systems use natural light to supplement artificial lighting. Evaluate the power quality of the electrical system. Power quality problems, such as voltage sags and harmonics, can damage equipment and disrupt operations. Consider using power conditioning equipment to improve power quality. Power conditioning equipment can filter out noise and stabilize voltage. Explore the possibility of using smart grid technologies to improve the reliability and efficiency of the electrical system. Smart grid technologies enable real-time monitoring and control of the electrical grid. Evaluate the cybersecurity risks associated with the electrical system. Cybersecurity is an increasingly important consideration for critical infrastructure. Consider using fire-resistant cables in high-rise buildings and other critical facilities. Fire-resistant cables can help prevent the spread of fire. Explore the possibility of using low smoke, zero halogen, or LSCH cables in enclosed spaces. LSCH cables produce less smoke and fewer toxic fumes in the event of a fire. Evaluate the environmental impact of alternative wiring methods. Environmentally friendly wiring can reduce pollution and conserve resources. Consider using recycled materials in the electrical system. Recycled materials can reduce waste and conserve resources. Explore the possibility of using renewable energy sources, such as solar and wind power, to generate electricity. Renewable energy sources can reduce reliance on fossil fuels. Evaluate the life cycle cost of alternative wiring methods. Life cycle cost includes the initial cost, operating cost, and maintenance cost over the lifetime of the system. Consider using predictive maintenance techniques to identify and address potential problems before they occur. Predictive maintenance can reduce downtime and extend the life of equipment. Explore the possibility of using remote monitoring and control systems to manage the electrical system. Remote monitoring and control can improve efficiency and reduce operating costs. Evaluate the training and certification requirements for electrical workers. Properly trained and certified workers are essential for safe and reliable electrical system. Consider using Building Information Modeling, or BIM, to design and manage the electrical system. BIM can improve coordination and reduce errors. Explore the possibility of using virtual reality, or VR, to train electrical workers. VR can provide a safe and realistic training environment. Evaluate the ethical considerations associated with the electrical industry. Ethical conduct is essential for maintaining public trust. Consider using sustainable procurement practices to reduce the environmental and social impact of the electrical industry. Sustainable procurement can promote responsible sourcing and manufacturing. Explore the possibility of using circular economy principles to reduce waste and promote resource efficiency in the electrical industry. Circular economy principles aim to keep materials in use for as long as possible. Evaluate the role of technology in shaping the future of the electrical industry. Technology is transforming the way we generate, distribute, and use electricity. Consider using digital twins to simulate and optimize the performance of the electrical system. Digital twins can provide valuable insights and improve decision-making. Explore the possibility of using artificial intelligence, or AI, to automate tasks and improve efficiency in the electrical industry. AI can automate tasks such as fault detection and predictive maintenance. Evaluate the impact of climate change in the electrical industry. Climate change is creating new challenges for the electrical grid, such as increased demand for cooling and more frequent extreme weather events. Consider using microgrids to improve the resilience of the electrical grid. Microgrids can provide local power generation and distribution. Explore the possibility of using energy storage systems to improve the reliability and flexibility of the electrical grid. Energy storage systems can store excess energy and release it when needed. Evaluate the role of the electrical industry in achieving a sustainable energy future. The electrical industry has a critical role to play in reducing greenhouse gas emissions and promoting energy efficiency.